Welcome to the third video, an emergency review on our linear and quadratic functions assessment. In this video, we will look at the long response problem that was at the end of paper 2 on the assessment. So let's take a look. The problem from the math test was this one. For a CAS project, a small group of students starts a small business selling natural water filtration units online. At 32 euros each, they sell an average of 56 units per day. They estimate that for every price increase of €4, they sell 2 fewer units. A. If X represents the number of price increases, write an expression for price after X price increases. Okay, so we have to begin like this. First of all, the original price was €32, and each increase of price increases the price by €4. Therefore, after X increases of price, so we have some number of increases of price, each one giving 4 more to the price, so therefore our new price must be 32 plus €4 times however many times you're increasing the price. Okay, then we're going to look at B. Write an expression for the number of units sold following X increases in price. So units sold originally was 56. And now, just like we did this one, we are selling fewer units, 2 fewer units every time we increase the price. So after X increases in price, we're going to have fewer units sold. That means 56 minus 2 fewer units for each increase in price. That's the very important starting place for this problem. Make sure you understand exactly how those expressions were created. Now let's talk about C. C says show that revenue is this equation. Revenue is money made. It is different than profit. Revenue is all the money you collect while doing business. So revenue can be found by doing the number of units you sell times your price, right? If you sell 10 hats and you're selling hats for €5, 10 times 5, 50 is your revenue. In this case, our units sold is 56 minus 2x, and our price is 32 plus 4x. So we're leaving the X unknown because we're going to find the best revenue later, but right now we just know that's what our revenue will be. If you multiply those out, you will get that expression that you see there, or that equation. All right, let's continue. And that revenue, oh sorry, I took one step further right there. Okay, let's go to the next step. Use your model to state the y-intercept and describe what this point represents. The vertex also, and the x-intercepts. So we have this revenue model, which is definitely quadratic, so it will have a vertex, y-intercepts, x-intercepts, all that. Let's analyze it. The y-intercept is always the c-value, so it's right here, 0, 1792. What does this represent? Well, imagine the revenue model, well, 0. Well, okay, first let's go back to the model. The model is revenue, which is like your y value. So your y-axis is revenue, and then the x-axis is whatever x is. And if you go back to what x was in the problem, x is the number of price increases. So this tells us then, at 0 price increases, this is the revenue we had. Okay, 0 on the x-axis is 0 price increases, and here on the y-axis is our revenue, because it's revenue here. So the revenue when no price increases are made. So that's the money we make if we don't change the price at all. Okay, next. For B, we need to find the vertex. We have standard form. We can use negative b over 2a to find the vertex. Negative 160 over 2 times negative 8, which is negative 16, equals 10. So our vertex occurs at 10. Again, this formula finds us the x value. So that tells us our revenue has a peak when we've done the price increase 10 times. So we put that 10 back in the revenue, and we find out this is the revenue. And we can see that that's much higher than the original revenue. So by increasing the price 10 times, and remember each time we increase it, it's actually increasing it by 4 euro. So we actually increased the price by 40 euro, and still we had way more revenue. Okay, so now that we have that, we can find the x-intercepts. So here's our maximum vertex point, and now we can find the x-intercepts. Oh, explain that in words. So the number of price increases that leads to a maximum revenue, and I was just explaining that 10 price increases leads to this maximum revenue. All right, x-intercepts, you can use Poly Simulation 2 on your calculator for this quadratic or quadratic formula, and anyway, you get these answers, negative 80 and 280. So those are our x-intercepts. What do those represent? Well, they represent the number of price increases that lead to no revenue, because at x-intercepts, the y value is 0. therefore there's no revenue. So if we increase the price 28 times, then we end up with no revenue. But if we increase it 10 times, we get that maximum revenue. All right. Let's keep going. Sketch a graph. So you should have that. You can use your calculator to sketch it and then draw it on paper. So if you put on your calculator, you should be able to see this kind of function. So here it is, and here's the main points we just found. Here's that revenue when no price increases, right? The y-intercept. There's our maximum revenue when there's 10 price increases. Here's 28 price increases that leads to a revenue of 0, y value of 0. Here's the other one on the negative side. So there's our sketch for revenue. And when it says sketch in our course, it means it can be a rough sketch like this. There's no units marked on here, but the key points are labeled. Okay, next one. Associated with a small business are costs. The students estimate that costs will be 2,200 when one price increase is applied, and costs will be 2,600 after 17 price increases. So it's basically telling you an x and y value, right? Because price increases are your x values, and then the revenue or cost, which is basically just money on the y-axis. So it's giving us coordinates now. So we are told a coordinate of 2,200, which is one price increase, and then this cost. And then 2,600, which is this other piece of data here, gives us another point. So that's one point, and that's another point. You got to read those words and see, oh, they're giving me coordinates. And if they give me coordinates, we can make an equation. So we're going to use, that's going to be a linear equation. So we're going to find the slope of that. And we can see the linear equation there, right? So we find the slope of that, y2 minus y1, and then x2 minus x1. That is 400 over 16, which is 25. So we know the slope of this cost equation is 25, and we see it there. We've just confirmed it. And now we can use the point slope form to find the equation of that cost line. Y minus, I'm using this point here, y minus 2,200, there's a slope, x minus 1, and then that rearranged gives us the equation we see here. So now rather than having y, I can rewrite it as costs. And now we have our cost function, which is a linear function. Okay, add this cost function to your sketch. So we have our original sketch, and now I'm adding the cost one, which is a line. But I don't know where to draw the line exactly. I want to be as accurate as I can. So what I'm going to do is I'm going to take an x value of 20 and just put it in there. I could have used any point I want, but basically I already know the y-intercept is 2,175, so it's going to be something like here. But I want to find another point, because if I have one point and another point, I can connect them and make my line. So I'm going to put 20 into this function, and it gives me this number here. So now that I have that, I know that point is there, 20, 2,675, and my y-intercept, which is this value, is here. Connect those, and I have my line. Right? 2 points are enough to make a line. There's my cost line. Okay, show that the profit function is this. Now we talked about profit. Profit is revenue minus costs. Revenue is all the money you get into your business, and of course then you have to pay for costs. So revenue minus costs is your profit. So we're going to begin like this. Profit, money remaining after costs are covered. So profit equals revenue minus costs. So our profit function is going to be our revenue function, which we had from before, minus our cost function. Notice the minus here applies to both of those. So I put that in parentheses. You're subtracting both. Now when you combine those both become negative, and then combine like terms, and I get that. So I've shown that the profit function is the same as that. Okay, I. Find the number of price increases that will lead to maximum profit. So we need maximum profit. So again, we're looking for the max point of this parabola. So maximum profit, negative b over 2a, will give us the x value of the vertex. Negative 135 with that, 8.4. 8.4 put into the profit function gives us this value. So we know our vertex of the profit function is 8.4, 186.5. Okay, let's see what that looks like on our graph. Oh wait, sorry, that's going on here. Okay, there's our profit, there's our graph. So where is that profit? So we already knew that revenue, purple, was maximized right here when we did 10 price increases. But now we're finding out that that profit is maximized at 8.4 price increases. So why wouldn't there be a maximum profit when there's maximum revenue? Well, that's because of the cost line. Maximum profit is where we have the maximum difference between revenue and cost. And if we look at from here to here, because this is 8.4, the point we just found for maximum profit, from here to here, that's the largest gap between revenue and costs. In other words, that's where we're making most profit. If you go to 10, which we found to be our maximum point on the revenue graph, well, that's maximum revenue, but costs are higher, so the gap between the two there is actually smaller than the gap here. We have just found where the largest gap is. It's right here. And also, it's important to see the green function is my profit graph. So I graphed the profit one, and you can see the profit one maximizes as a max point right here. And that matches right here with the biggest gap here between revenue and costs. All these things are really important to understand how to interpret this. And finally, also, let's take a look here. Here, green shows us no profit right here. And that makes sense because right there, revenue and costs are the same. This is a break-even point. Revenue and costs are the same. Therefore, no profit. So you can see, look, profit is 0. And over here also, revenue goes down, costs go up, and we have revenue and costs equal again. That means break-even point, no profit, and we can see 0 profit right here. It makes sense. Everything makes sense. And here, revenue is below costs, so that means we're actually not making any profit. We're losing money, and you can see profit goes into the negative. We're losing money. And the same here, revenues dip below costs, so we're losing money, and you can see profits are going into the negative also. All important stuff. All right, what's next? Okay, solve the inequality, this. So costs greater than revenue. Here's cost function, here's revenue function. We're going to solve this. That, I move everything to one side to get this. And then I am taking this parabola, this quadratic, I'm going to solve it on the side here, equal to 0. I'm ignoring the inequality for a moment, setting it equals 0, and I found out there's two solutions there, these values. So now I'm going to take those two values and consider the parabola. So I'm saying when we have an inequality, remember we have when is this parabola greater than 0? In other words, when is this parabola positive? When is it greater than the line y equals 0? And I look at the parabola. I know this is a parabola that is concave down because of this negative here. So here's the parabola, and when is this parabola less than 0? When is this parabola below 0? Well, it's below 0 here and below 0 here. And I just found out those two x values are 3.6 and 13.3. So this answer to this inequality is when x values are less than 3.6 and when x values are greater than 13.3. That's when this parabola is less than 0. So those are our answers. And what does that mean in terms of the problem? Well, it means this represents when costs are greater than revenue. That's when we have a loss. So we know we have a loss when the price increases was 3.6 or lower, or when the price increases were 13.3 or higher. That's when we have a loss, because that's when costs are greater than revenue. Let's take a look at that on the graph. So there's on the graph, and we can see 3.6 is right here, and we can see 13.3 is going to be right here. And that makes sense. Those are our two break-even points. That's when revenue and cost are equal. So when we are below 3.6, here's 3.6 price increases. When we are below that right here, costs exceed revenue. And when we are above 13.3 price increases here, also costs are greater than revenue. All right, great problem. Let's take a look. For you to try one now, try this one out. This one was inspired by a recent visit I took to an old moija in the countryside, and they were making juice there. Okay, check your work. Here's the original price, here's the price with the increases, here's the original units sold, and here's with X increases, the units sold goes down by 3 units each time. So check those. Therefore, our revenue model is this, units sold times price, simplifies to that. Therefore, we can find the, oh, now we're doing costs. There's the slope of the cost points it gave us. There's the cost equation that we can come up with. And finally, we can do profit, which is revenue minus cost. If you do that one minus that one, you get that one. Check all your work very carefully. And then your job is to interpret the points. So you have these graphs. Check your graphs. You should have tried sketching them. Here's our revenue. Here's our costs. Here's the profit so you can compare. And your job is to look at all the points. So here's some key points. Take these key points here and be able to respond. What do they mean? What do they represent in terms of the real scenario? Try it now. Okay, I don't have full answers here, but those points, I have the points labeled for you. You should check your work. There's all the points, and there's kind of the descriptions of what they all mean. But you should be able to elaborate more than that you should be have a deeper understanding of those. Great work. We'll